All right, on to problem number 5. A ship is 4 miles east of a lighthouse. All right, so this is going to start getting into our compass again. So it's always beneficial to draw it out. So north, east, south, west. And we're going to say that the lighthouse is this origin point. So a ship is 4 miles east of the lighthouse. We're going to call that 4 miles and straight east. Another ship is 3 miles southwest of a lighthouse. If you are told southwest, northeast, any of the kind of combination directions, that's basically saying it is directly between south and west. So the ship is down here 3 miles. Okay. Now it's asking, or I am asking you to figure out how far apart are those two ships. And when we figure out distance, it's always a straight line between them. Okay. Now, what we're going to need is this angle. Now, every direction on the compass, if there's two right next to each other, so north and east, north and west, those are all 90 degrees apart from each other. If we split the difference between them, that's going to be a 45-degree angle and a 45-degree angle. So what we've got here is the 90 degrees from east to south, and then another 45 degrees from south to southwest. So that gets me a total of 135 degrees. And I'm going to zoom in on that picture so I can write 135 degrees right there. So this is absolutely law of cosines. So we've got x squared is equal to 3 squared plus 4 squared minus 2 times 3 times 4, cosine of 135. Everything on the right goes into a calculator, whether you're using Calculate 84, Desmos, your own personal calculator. Always make sure for these problems that you are in degree mode. Some more stuff after that. So 41.97 and some other stuff. Square root both sides. Because x is a distance, we're going to go ahead and ignore the possibility of a negative answer. So 6.48, I believe we're talking miles. We are. So the two ships are almost 6.5 miles apart. I'm going to rewrite the word miles here because that's just, I think I've tried writing it 4 different times and it's just having issues. Much better. All right. So that's problem number 5. Problem number 6. At noon, 2 cars leave a junction of 2 straight roads. One car is traveling at, let me start annotating this, 50 miles per hour. The other one is at 41 miles per hour. Path of the cars forms an angle of 72. All right, how far apart are the 2 cars at 3 p.m.? Well, 3 p.m. would be 3 hours of time. So from noon to 3 p.m. is 3 hours. So we're going to say here's our little junction. One car covered 150 miles. We've got a 72-degree angle here. Let's see, 41 times 3 is 123 degrees. Not 123, 123 miles. How far apart are the 2 cars at 3 p.m.? So we're looking for this distance right here of x. So let's go ahead and set up that equation. Law of cosines, of course. X squared is equal to 150 squared plus 123 squared. Minus 2 times 150 times 123, cosine of 72. And you'll notice I have not in any one of these problems referenced like where's A, where's B, where's C. With law of cosines, what you want to focus on is the angle that you know or want to know, and then the side opposite it. That's the focus of start here, end here, and everything in the middle is going to use the 150, in this case, in the 123. So kind of get the feel for how that problem looks. Everything on the right goes into the calculator. So minus 2 times 150 times 123, cosine of 72. All right, so x squared is equal to 26,226. Want to write an extra 2 there. 0.27 and some more stuff. I'm going to take the square root of both sides. Again, x in this case is a distance, so I get to ignore the possibility of a negative answer. And 9.5 if I round, and we're talking about miles here. All right. All right, so that's another video taken care of. I'll pop up a separate one for the rest of the worksheet or some of the problems in the rest of the worksheet. If you've got questions or concerns,